Hello and welcome, and here I am on doing a full screencast. I hope so. It will be 720p on YouTube. I really hope so, if YouTube allows me. Maybe not. Okay, so actually I get several subjects for this video, and this is not a tutorial. As you can see, so this is not coding tutorial or anything. I actually wrote down what I want to say because I forget it. My memory is a little short. Okay, so first of all, if you have any FPS game ideas, I don't know, making multiplayer FPS game or making a how does it called, the cross aim thingy in the center of the screen, or sniper rifle or something, anything that comes to your mind, just write down the comment below and I try to implement it and make a video about it. So this FPS game will be like I continuously updating this FPS game. So now at the current state it's very crappy, but more FPS tutorials come up and I will, you know, add continuously new stuff to it, and I hope that it will make it a little bit better. Okay, so the upcoming tutorials, although I'm not finished with the FPS games yet, as I said, more tutorials will come up about the FPS games as well. And there are several tutorial subjects I want to go back with to the SDL a little bit, like multi-threading and networking. So maybe I can make this FPS game a multiplayer FPS game, which would be really cool actually. So multiple player could play on the same map and shoot each other instead of zombies. Alright, and what else is here? Box 2D, it's a physics engine. I will show you a demonstration about that in a moment. Not a too cool demonstration, but a relatively good demonstration. Okay, so GLSR for OpenGL shaders, which is actually the new OpenGL. So nobody really uses GL, so this GL vertex. Yes, so this which we have done earlier with OpenGL, because it's a bit old. I say it's usable definitely since we make an FPS game with it, but we can increase the quality of the image, and actually we can do much more stuff with GLSL. So that's what will come up, like per fragment, so per pixel lighting and normal mapping. So that will come up eventually, although I still have to a little bit renew my knowledge on the GLSL, since it was a bit so it was a long time when I did GLSL. Not that long time, but actually quite long time. Okay, and a few OpenGL, so simple OpenGL tutorial like height mapping and things like that, maybe advanced textures, something like that I come up with. And actually the last thing, the main thing I want to do in this tutorial is actually show some of my programs. Although I didn't have that much time of programming, I would hope so. And by the way, all of the source code and project will be on the description, maybe with something, so you will find it. Okay, so first of all, let's start with the letter A, which is an Angry Bird clone I wrote. So here it is. I hope you can see it. So I use the Box 2D physics engine to do the physics stuff with it. So I didn't play actually with this game, so the original game. I just saw YouTube videos about it and I tried to make it so I can shoot this bird, as I said, shoot, and there we go. And actually this physics simulation is not that complex, but so it's relatively simple to make with the Box 2D, but if I would have to program myself how these blocks do when they colliding, that will be a bit complicated. But the Box 2D has much more capabilities than just simple collision detection and response. Yeah, I won. So it has much more capabilities, and I probably go into that. I will think about that, how deeply I want to go into the Box 2D. So this project will be on the description, and yeah, okay. So I make add the description how to compile it, because it might be a bit complicated. It's not just as simple as writing a command. You have to copy this box2d folder, which contains the include files somewhere, contains the include files, to your include folder, which is in Linux. It's places, and so the slash my own computer, and usr, which is Unix system resources, not user, and here we have the include. So you have to copy that folder, box2d folder, right here, and then you have to copy the ls, so this lib file I created. I will show how to create lib file, by the way, to your lib folder. I think that should cover it. If not, that I will try to compile again and write a description. Okay, the next is an A* algorithm. It's a simple algorithm which search I don't know. So the distance between 2 points, which is the shortest. The shortest distance, that's what I wanted to say. So I can make a start point, an end point, and make a wall between them. So yeah, this is a wall. And if I press, I think it was U, then it will search the slowest, shortest way between the two. Of course, I can do whole labyrinth with this. So I can make, oops, let's start it again. So I can make something like this. My computer is a little bit slower now because of the recording, so I can do this. So it's like that. So the start point is here, the end point is here. Press U, and there we go. It's fine. In theory, this is the shortest way. Maybe not. So maybe my implementation is not perfect, since I just go to Wikipedia and try to get that pseudocode into C++ code. So I'm not sure if this is the perfect way or not, but it seems that it does work. Okay, I don't need that anymore. Next thing on the list is this simple Asteroid game, which is actually, I just write a demonstration to demonstrate the rotation. So the rotation in SDL, because yeah, so that's cool things in a game, if you can actually rotate, not just go to forward, backward, left, right, but actually go any direction you want. So this is just a simple demonstration to demonstrate that. Now let's blow the ship up. That's right. Okay, I will want to make a tutorial in SDL about that too. Not this game, but actual rotation stuff. So how to rotate with SDL GFX, with the header, with the file SDL roto zoom file, how to do the rotation, and actually yeah, how to move in the rotated direction, and how to rotate yeah, that was okay. Next thing is a bignum library. It can handle big numbers actually, and it's not too interesting since it don't have any graphical output. You can pretty much use these big numbers as any integer to almost any place. So you can create a bignum b1 and just make it some number 123, make another one bignum b2 and make it some other numbers, and for example you can just write out, so std cout, and write out for example b1 times b2 and make it an std end line. Okay, we don't need file. Okay, I just opened the test file basically and included this bignum.h file, and the bignum.h and bignum.cpp is basically what this video is about. Okay, so I just write out the multiplication, so b1 times b2, and if I get a terminal right here, so this is the demonstration folder, dem, right, and cd bignum. Okay, and let me just compile the test2.cpp and the bignum.cpp file. Okay, it's compiled, so if I run it, it's write out what is 123 times 321. I hope this is correct, so let me just do it with the building calculator. So 123 times 321, 39,000 something. Yeah, it's correct. Okay, the interesting things about this bignum class that it can handle basically any number between 0 to 4 billion digits. So I can make a number like this. I can give it as a string literal, so as a character literal, and actually just add some big number like this. As you can see, that's a fairly big number. Okay, let me write some number right here, and let the b2 be some other big number, like I don't know, this, and I can use pretty much the same operation. So I multiply b1 times b2 and I get a pretty big number. So if I compile this and run it, as you can see, this is the result of the multiplication of the two numbers. So it's pretty big number, I would say. Okay, and of course I can do the division as well. So if I do that, it does the same thing as with integer, so it's a whole division, not a floating point division. So the, you know, after things, so after the point, floating point, it will so yeah, I think you get it. I don't even know. Okay, I can use the modulo, which is the modulus, similarly as we would do with any other kind of integer. Okay, I can do, what else can I do? Add, multiply, subtract, so basically anything you could imagine for a simple integer. Okay, and for example, let's make with this bignum class a simple program which calculates some factorial. So make a big number, and this will be b1, and start from 1, and make a loop. So for int I equals 0, actually make it 1, I less than 1000, I plus plus, and just bignum times equal I. So this basically just calculate a factorial, so 1000 factorial. So if I compile, actually write it out afterward, and not bignum, b1 is my variable name, so b1 times equal I. And let me just write out the b1, so std cout b1 std and line, and line, and this is a column. Okay, let me compile this program and run this, and if everything goes well, this is 8000 factorial, which is pretty big number. And I have actually calculated 100,000 factorial just for fun. So if I cat it out, I wrote it in a file, and this is it. It's a pretty long number. There are a few zeros at the end. Okay, and if I use the VC, not the water cleaning toilet, but actually the VC as the word count, it's a built-in Linux program which counts the number of lines, words and characters in a file, and use this in this file, then I see that it is 400,005, so it's a pretty big number, more than 400,000 digits long, and this big number class actually can handle that. By the way, I have verified this number, so it's correct. Not every digit, but the first and the last one seems correct, so I guess the rest are too. Although, because it uses a slow multiplication, it gets quite slow after about, if I want to multiply 1000 digit by 1000 digit, it's almost take a second, which is unacceptable in a good program, mathematical program. So I recommend you to actually use some other libraries for big number handling if you want to do actual useful stuff with it, but it will be good for demonstration since it always gives a good result, and you can learn something from it. So I don't know, go through and just look through the algorithm. Most of them are pretty much the same as you will do in paper, so the addition, subtraction, multiplication, so just with a bit of dynamic memory handling. Okay, I will make a tutorial about that, but not correctly this game, not about this game. By the way, you probably already realized I will not make tutorials for this program, but if you want, then I can, obviously. So if you want the tutorial for some of these programs, then let me write down the comment section, and I will read that and do the tutorial if you write it down. Okay, then this is next, as I really like this. Actually, this is not my own algorithm, my implementation, but not my algorithm. I just, aimlessly wandering around YouTube, and I found a video, I'm not sure about the link of that video, which implemented this algorithm to some platform, with some graphical library, I'm not sure which one, and I really liked it, and there was a link about this, which should be in the description as well, to how to make this. This is the water effect, which is pretty cool. You can click on this and it's like water. It's relatively cool, and the algorithm is not that complicated. It's just a few lines, I don't know, 10 line of algorithm if we don't count the SDL and C++ initialization crap. So it's pretty cool. You can make the water. I'm not sure if it has actual practical usage, because I don't know. I don't think that you want to use that in a game, but if you want, so then here you go. And I make a rain, which is basically the same, except that randomly pointing spots and creating this rainy effect, which is pretty cool again. Okay, the other is I continued wandering around in YouTube and then find a fire algorithm. Maybe the link will be in the description, and it's pretty cool. It's actually just creating a low line. Actually, I will not tell you the algorithm right now. You can find that in the CPP file if you want. So by the way, you need 640 and 480 for this water algorithm. One cool thing about this, that no matter how much water thing you create, bubbles or what the hell are those, waves, maybe that's a better word for that, it will not slow down the algorithm. It's relatively slow algorithm, because we have to go through every pixel and do some stuff with some mathematical stuff, but actually not matter how many of these you create, it doesn't slow down the algorithm, because it does the same thing basically. Okay, back to Tetris. It's a little Tetris game. I originally wanted to make a tutorial about that, so it is very well commented in the file. As you can see, almost every line is commented, as I used to do. Pretty simple algorithm. I don't say it would be too complicated. As you can see, the normal Tetris game, so you can do stuff like that. And yeah, okay, so nothing to talk about this. It's pretty simple algorithm. You can find it on the in the source code as well. Okay, let's just make a game over right here, and I actually have a top list as well. So although I haven't implemented top list any of the earlier tutorials, here there is a top list, as you can see, and actually I could get into this top list if I have high enough point. Alright, actually make this top list empty. So make this top list empty, so I can get into the top list and show you how does it look like. So I get into the top list with 0 points. So here it asks to write my name, so I write my name into, press enter, and I get into the top list. So here I am in the top list with 0 points. Next is a little program to demonstrate recursion, and actually BMP, image save, and line, the drawing lines as well. So it's a multiple program. It does everything. It draws lines, it saves BMP image from a surface, and it is a good example for recursion. By the way, here are the constants which I will refer later on, so you can change these constants and make your own effect if you want. So here is the save BMP algorithm, not that complicated. It's basically just the algorithm from Wikipedia. So how does the BMP file look like, and just fill up these structures which I copied from Wikipedia as well, and write out into a file and write out all of the pixels. Similarly, you can do the loading in, just you have to read in the opposite direction, obviously. So there it is. It saves out a BMP image, and here is the algorithm. As you can see, we can see how does it draw the tree. Obviously, I slow down the algorithm as it will be immediately complete. I use the SDL delay, so it will not be so quick. And as you can see, we can watch entire day how this tree will look like. But actually, I go into the main.cpp file, although I can't stop this right now. Yeah, I'm on it. So kill this application and let's go into the main file. So cd my desktop, demonstration, and the Treedrawer. And if I rewrite this stuff right here, by the way, this is not my algorithm, this lining thing, neither. It's from Wikipedia as well. I stole everything from Wikipedia. Okay, so if I just exit from this delay, so I will not delay anymore, and I compile the program if I can. Maybe I can. So I compile the main.cpp and I use the SDL flag. Right, it's compiled. And now if I run the program, so here it is, then as you can see it's immediately finished and saved out the BMP file, which I can open right now. So that's how it look like. Obviously, if I change these constants right here in the top, there will be a different tree. Like if I change the angle, the number of the, how does it call, I don't know, it's the lines. Okay, I call it lines. So for example, I change it to 4 instead of 6, and again compile it and run it, then it will create a different tree which look like this. So it's a mathematically perfect tree. The other program is just a little tweaking of this program to make it such weird trees. I guess it's a bit more real looking trees. I wouldn't use it in a game, obviously, it's not that well, but it might be a good example for recursion. You can see a lot of things and some trigonometry functions. Okay, that was the Treedrawer, and one left program left. This is actually a practical usage for the A-star algorithm. This is a clone for a Windows game. I said I stole all of my programs. And here the purpose of this game is to actually make these little balls into 5 in a row, in a column, or in diagonally. So as you can see, the algorithm for the A-star algorithm designed what these balls, what path they are going. So as you can see, they are going in the same path. Every time you move a ball, 3 new balls will come up. You see, I took bullets. I played too much FPS game and created too much FPS game. And whenever you actually able to make 5 in a row, column, or diagonally, then there are no things come up, so no new balls. Right, so of course the game is over when this entire table is filled. Of course there is a constant which you can easily change to make this table smaller, and yeah, that's pretty much it. So these were the simple program demonstration. I don't think that I have anything else interesting, although I can check. No, doesn't seem like I have too much interesting stuff in here. No, no interesting stuff. These are boring stuff. Okay, so again, if you have any FPS game ideas, go down to the comment section and write something to me. I will read those, and if I can, I will make videos about those. And of course, thanks for watching and have a great day. All of this program will be in the description, by the way, if you didn't heard me in the first time. So thank you for watching and have a great day.